So tell me what you guys know about right triangles. What do you know?
Have a 90-degree.
Okay, they have a 90-degree angle. Obviously, that's what makes them a right triangle. Do you know anything else? Yes, that is true. Oh. Okay, so when you square each leg, so the legs are the ones that make up the right angle, when you square those and add them together, it equals the hypotenuse squared. And that is also called the Pythagorean Theorem. The hypotenuse is the side opposite of the right angle. So let's draw a right angle. A right triangle. That's what I meant. Sorry, this we're going to say that's not really a right angle. I'm going to try to do better. Okay, so if this is our right triangle we're looking at, and we know this side is 27 feet, and then we know the hypotenuse is 30 feet. And remember, the hypotenuse, like I said, is always opposite of the right angle. And the two legs are the sides that make up the right angle. So this would be a leg, and we're going to say this is leg A, and we'll say 27 is leg B, which makes C the hypotenuse. So in the Pythagorean theorem, it is A squared plus B squared equals C squared. Who remembers this a little bit, hopefully? Okay, and then we plug in what we know. We don't know A, we don't know one of the legs, but we know the other leg is 27, so 27 squared equals the hypotenuse squared, which is 30. And hopefully everyone has a calculator. So, what is 27 squared? Can someone tell me that? 729. So we have A squared plus 729 equals, what's 30 times 30? 900. And then to solve for that other leg, we're going to subtract 729 from each side, right? We get A squared equals what? 171? So if A squared equals 171, what would A equal? 13, because we take the square root of each side. 13.1? Okay, so for rounding to the 10th place, it will be 0.1, correct? Okay, so A is going to equal 13.1 feet. And that's how you use the Pythagorean theorem to find one of the sides that you don't know. Just make sure when you plug it in that C is the hypotenuse and C is always the longest side. Okay, so if you solve a problem where the hypotenuse is shorter than one of the legs, then you know you did something wrong. Okay? All right, so that's a review. And now we're going to talk a little bit more about right triangles. And I need you to write some stuff down below that. Okay? So write this stuff below that. It's regarding right triangle trig. Sorry. There. And that little oval with the line through it is called theta. Oops. Theta. Yeah, it's like a zero with a line through it. We are on page 37, okay? And leave a few lines at the top because we wrote some stuff above this. Okay, so theta is always an acute angle. What is an acute angle? Less than 90, right? So the sine of theta is always going to be the opposite side over the hypotenuse. That's an H. And I'll explain more in a second. So cosine of theta is always the adjacent side over the hypotenuse. Tangent of theta is always the opposite side over the adjacent side. And cosecant, so these here are the reciprocals, gotta sound it out, of these up here. So cosecant is the reciprocal of sine, or the inverse of sine. So the cosecant will be, instead of opposite over hypotenuse, it will be hypotenuse over opposite side. Okay, and secant is the reciprocal of cosine. So instead of being adjacent over hypotenuse like cosine is, secant will be hypotenuse over adjacent side. And cotangent, this one's easy to remember that they're reciprocals, but it's the reciprocal of that, so it'll be adjacent over opposite. Okay? Yeah, hold on one sec. So then I want you to remember this saying and write it. And this will be the last thing that you can write on page 37. So write it as large as you can. Is this saying SOHCAHTOA? Have any of you heard this saying before? You have? Did Mr. Shumway teach it to you? Okay, SOHCAHTOA. Bold, highlight, whatever you need to do. Because SOHCAHTOA is a short way to remember the ratios. Because sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you remember that saying, and especially how you spell it, then you'll remember the ratios. Okay? All right, so theta is always an acute angle. And wherever theta is, because if theta is right here, like we had in our notes, the opposite side is obviously directly opposite of the angle. The adjacent side's always next to, that is not the hypotenuse. Because the hypotenuse is always what? Opposite of the right angle. Okay? All right. So questions so far on this? Those of you that walked in late, I will come back to this in a minute. Go to page 38. We're going to do 2 examples on page 38. SOHCAHTOA stands for the S, like in so, S is the sine, so it's opposite over hypotenuse. That's you. C stands for cosine, adjacent over hypotenuse, and T is tangent, opposite over adjacent. Okay? All right, so let's write on the top of page, what are we on again? 38. Okay, top of page 38. Let's write right triangle trig examples. Okay, you don't have to write the instructions here. But you do need to draw that right triangle for me, please. And where theta is located. Okay, so what we're going to do here is we will name all of the ratios of the 6 that we learned. So sine, cosine, tangent, and then the inverses of those. Okay, so let's start with the main 3. So let's do sine of theta. So if theta's here, remember sine's what? In SOHCAHTOA, sine is opposite over hypotenuse. So what is the side opposite of theta? Directly opposite is the 8 over the hypotenuse is opposite the right angle. So the hypotenuse is 17. So 8 over 17 is the sine of theta. Then we do cosine of theta. And so SOHCAHTOA, so cosine is adjacent over hypotenuse. So what is the side adjacent or next to theta that's not the hypotenuse? 15, right? So then it will be 15 over the hypotenuse is 17. And the tangent of theta is the opposite, because SOHCAHTOA, so it'll be opposite over adjacent. So opposite is 8 over adjacent is the 15. So 8 over 15. If you can reduce the fractions, obviously do so, but we cannot. So now let's do the inverses of all of these, okay? So inverse of sine, when you think of cosecant, secant, and cotangent, the inverse of sine is the one that doesn't start with s. That's how I remember it. So that's going to be your cosecant. And it's just the reciprocal, so it'll be 17 over 8. Inverse of cosine is the one that doesn't start with c. So that's the secant. And if you need to look in your notes, then you can, because it's the one directly under it is the reciprocal, okay? So secant is going to be what? The reciprocal of cosine, so it'll be 17 over 15. And cotangent's easy to remember because it is the reciprocal of tangent, which is what? 15 over 8. Okay? Okay, let's do one more example. Then we'll be done with our notes. So draw that right triangle and put theta in the top angle, top corner. So on this example, do we know the hypotenuse? No. Can we figure it out? Yes, using the Pythagorean Theorem, right? So are these, the 5 and 12, the legs? Yes, right? Because we don't know the hypotenuse, so we don't know what C is. So then if we go 5 squared plus 12 squared equals C squared. What's 5 squared? 25. What's 12 squared? 144 equals C squared. I think when you add those up, it'll be 169 equals C squared. Take the square root. What's the square root of 169? 13. So C equals 13. So now that we know all 3 sides, what I would like you to do on your own is go ahead and identify all 6 trig functions. So sine, cosine, and tangent, start with those, and then do the reciprocals of those. So cosecant, secant, and cotangent. So I will give you a couple minutes. So for the sine of theta and SOHCAHTOA, sine is what? Opposite over hypotenuse. So what's the opposite side of theta? What's directly opposite of that is the 12 over the hypotenuse that we found out earlier right here was 13. Right? Cosine of theta is the adjacent over hypotenuse. So the adjacent side is the 5 over hypotenuse is 13. What about tangent? TOA is what over what? Opposite over adjacent. So opposite side is 12 over adjacent is 5. And then here you should have just done the reciprocals of all of these. So this would be 13 over 12, 13 over 5, and 5 over 12. Questions? Okay. In 1 second. Turn to the side that says page 75, the one with the 6 triangles plus the 6 more. Okay, so listen, problems 1 through 6. You have to do the exact same thing that we did in our notes, just barely. You name all 6. Okay? And since if there's not enough room there, then do it right here. Okay? On the bottom part of the page. Anyhow, what I wanted to talk about though was 7. All you have to do is use your calculator to find the sine of 9 degrees, but you want to make sure that your calculator's in the right mode. So everyone, I want you to follow these instructions with me, okay? Go to the home screen. So everyone on home screen, go to settings, which is number 5. Go to document settings, which is option 2. And make sure the angle, which is the second option down, is in degree, not radian. If it says radian right here, then hit your right arrow, select degree, and then go to here, which is make default, because you want to make that the default. Okay? And it will say, are you sure you want to? And you say, okay. That's it? Yep. So if it was already in the correct mode, then you're good. If it was in radians, then you need to change it. Change it to degrees. Okay, so then if we go to the calculator, everyone go to the calculator button, and let's just put in sine of 9. Now, all the sine, cosine, tangent, all of those values are in this trig button next to the 7. So everyone see the trig? Push the trig option, then you have to select which one you want. So we want sine. Did everyone see that? So trig, which is to the left of the 7, select sine, and then just put in 9. And that's all you need to put. Let's round it to the thousandths place. So will it be 0.156 or 0.157? 0.156. So that's all you need to write for those problems right there. Okay? Yep. Yep, that's the answer to number 7. So those, all you need to do is just plug it in. The other side, the one that says what do you call an occupied restroom on an airplane, that side is all having to do with the Pythagorean Theorem. Funny, you do have to do it. Okay? So you may work with a partner, but I am going to give you some time, probably half of the time tomorrow to work on this. No, half. Half of class. And the other half is? Tomorrow. Other half is a partner quiz on this. Okay? So you have the rest of the time today to work on this, but do know that you'll have half the class tomorrow. to work on this as well, okay? No? Any questions?